Let's say that I have a sequence of random variables and the probability limit of this sequence is some constant a. That means that if I create an arbitrarily small interval around a, then the probability that yn will end up in this interval will eventually become 1. So for a large n, most of the area of the density is in this interval. A common problem in probability theory is then to find the probability limit of some function of these random variables. If we start with a linear function such that z1 is some constant c plus d y1, z2 c plus d y2, and so on, then we will have a new sequence of random variables. And an interesting question is then, what's the plim of this new sequence? Without using the z notation, we are simply asking for the probability limit of c plus d yn. The result is that we can move the plim inside linear functions just like we can move expected values inside. The probability limit of a constant, that must be that constant itself, and then we have d times the probability limit of yn. So the probability limit of a zn is simply c plus d times a. We are not going to prove it, but intuitively it's not too hard to understand. When n is really large, then yn is a random variable that's very close to the constant a. So this whole thing will be a random variable that's very close to the constant c plus dA, and that's the plim. Expected values, they have this property as well. They do go inside linear functions, so the expected value of this zn is c plus d times expected value of yn. However, the plim has a property that the expected value does not, and this property is that it goes inside non-linear functions as well. So if g is just any function from r to r, and I create a new sequence of random variable where z1 is precisely this function applied to y1, z2 is g of y2, and so on, where g is now an arbitrary function, not necessarily linear. Then a very common question is, what's the plim of zn? That is, what's the plim of some function of yn? The result is that plim goes inside any function. So this actually comes out to be g of plim of yn. If plim of yn is a, this is g of a. Expected values, they do not have this property. The expected value of g of yn is certainly not equal to g of expected value of yn. This is the main reason for why plims are typically much simpler to calculate than expected values. We will not prove this super important result, but again, intuitively, as n becomes very large, yn is not acting as a random variable. It's acting more like a constant. So for large n, we're pretty much feeding a constant into this function g, and this is the reason why the plim is g of a. When we're dealing with expected values, we are not taking n to be large. N must be arbitrary, and therefore it cannot be moved inside this function. Let's say that I have two sequences of random variables, a y sequence and a z sequence, z2 and so on. I know that the probability limit of yn is some constant a, say, and I also have information on the plim of zn, which is another constant, let's say b. If I have two sequences like this, a common question is, what's the plim of the sum of these two sequences? Yn plus zn will be a new sequence. And the result is that this plim is equal to the probability limit of yn plus the probability limit of zn. So it's a plus b. Intuitively, for large n, yn is acting more or less like the constant a, Zn is acting more or less like the constant b, the sum of them will be acting more or less like the constant a plus b, and that will also be the probability limit. This result works no matter what function of these yn and zn you consider. So for example, the probability limit of yn times zn will be the product of the probability limits, so it will be a times b. You can of course consider other variations. The probability limit of yn raised to zn would be a to the b. So let's do one example from the most important Plim rule, this one. So let's say that x1, x2 and so on is a random sample. Then I know that the probability limit of this sequence is exactly mu, where mu is the expected value of xn. So what would be the probability limit of the square of the sample mean? The answer is Plim goes inside, so that's the square of the probability limit of xn bar. That is, it will be equal to mu square. Simple to calculate. If you want to calculate the expected value of the square of the sample mean, that would be a more difficult problem. It is certainly not the case that I can just move the expected value inside the parentheses. This is not equal to the expected value of the sample mean squared, which would be mu square. But for the Plim, it's simple. We move it inside no matter if the function is linear or non-linear.